Alright, I'm going to go ahead and solve all the problems on the review here. So let's get cracking. Okay, first one, we're going to use this formula. I'm going to change the v of t to a of t like we did in class. And then you have to change your window to be exactly this, which is actually a gift, because then everybody's graph will work out nicely. So x min, x max, x scale, all that means is that every tick mark stands for 50 instead of standing for 1 unit. Same thing for the y scale. So adjust your window, and then after you're done adjusting your window, then we're going to set up the equation. So we got a of t equals starting amount, so that's your principal, 400, and then it's going to be 1 plus, and then whatever the rate is. And remember, we changed the rate. We moved the decimal place 2 spots to the left, so 0.0375, and then we always divide it by n, and n is the number of times it's compounded per year. So if it says annually, then that's just 1. And then we're raising it to the nt, and so we're going to raise it to the 1 times t, or just t. And we're shooting for $3,000, so that's the amount of money that we want to have. So we're going to put that on the left-hand side. So 3,000 equals 400, 1 times 1.0375 raised to the t. And we're going to put that in the calculator. So it doesn't matter which side is y1 or y2, but one side of the equation is y1, the other side of the equation is y2. When you go to graph it, it's going to look something like this, where it starts off at 400, it's going to go up, it's an exponential function. It's going to have the other graph that's horizontal, so it'll intersect. And I did that one that intersected at a time of, and we'll just round to the nearest tenth, so the time is about 54.7 years. Okay, number 2. Okay, this one, same thing. We're going to start with a of t equals starting amount right there, 700. We are going to have 1 plus the interest rate, 0.042. We're going to divide it by however many times it's compounded per year. Semi-annually is twice. Then we're going to raise it to the nt, so that's 2 times the t. Okay, our goal is 3,000, so we're going to say 3,000 on the left again, and then equals 700. And then this, I'm probably not going to do anything, so I'm just going to leave it 0.042 divided by 2 raised to the 2n, or 2t. Okay, the left side, y1, right side, y sub 2. Graph it. Graph will be this, similar. Starts off at 700, has a horizontal line, and they'll intersect. And same window as before. So t for this one I got, it's approximately 35 years. Okay, number 3, same thing. We're gonna start off, we've got this time $1,000, and we're gonna do 1 plus, we're gonna do 0.03. It's compounded quarterly, so that's 4 times per year. So we're gonna divide it by 4, then we're gonna raise it to the 4t. The goal is 3,000 again, so we're going to put 3,000 on the left-hand side. It's going to be 1,000. This part, I'm just going to leave it alone. And then we're going to graph it. So left side y sub 1, right side y sub 2. Same looking graph, starts at 1,000, goes up. Horizontal line, just see where they intersect. All right, this one I got intersecting at 36.8. So t is approximately 36.8 years. Okay. Next one. Now we're going to talk about continuously compounded interest. So if you see the continuously compounded, that's not every year, it's not twice a year, 4 times a year, it's not even monthly, it's more than that, it's all the time. So if you see that, you're going to have a different formula. So it's going to be A of t, and then it's going to be the Perc formula. So it's principal times e raised to the RT. So we're starting off with 1,000, so 1,000. Then we have e, and we're raising it to the RT. So you can see the rate there. So we're going to move the decimal place 2 spots to the left, so 0.053 times t. Our goal is 3,000 again. That must pay for like a year of college or something, you know, at the community college. Yeah, that's about what it does. All right, so then we got 1,000 e 0.053 t. And then this side's your y1, y sub 2, y sub 1, either way. So you graph it, and your starting amount, again, the graph won't look really any different. It's an exponential function, got a horizontal line wherever they intersect. So for this one, I did it earlier, I got that t approaches, or t is approximately 20.7 years. If I'm looking at the right one, yes. Okay, the next one is also continuously compounded interest. So we're going to do A of t. We got the 950 we're investing, and it's going to be e, and it's raised to the 0.0275. See that decimal spot? 2 to the left. And then it's t. We don't know how long it's going to take. Our goal is 3,000 again. So I put 3,000 there. Got 950 e to the 0.0275 t. All right, the left side, y sub 1, right side, y sub 2. Graph it. You wouldn't know any different, just normal exponential function. Crosses there. And so for this one, I got, it's about 41.8 years. All right, now these ones you can do a couple ways. We learned how to do this, by, making this x, and then you can change it from logarithmic to exponential. So you can do 5 raised to the x equals 625, and then you can just try to think about, okay, 5 raised to what would give me 625? So it is definitely going to be a 4, but you don't have to do it that way. That's sort of like a guess and check way. What I would probably recommend is that you use the common base formula and you use your calculator. So we change this, we use the common base. So we do log 625 divided by log 5, and then we just punch that into the calculator. So when I did that, I got 4. So 4 it is. The next one, again, you use the change of base. So you do log, this part here is what goes on the top. The base makes sense, the base should be at the base, should be the bottom. So log 1 over 24 over 1 divided by log 7. Okay, when I did that, I got -4. All right, so same. We're just going to use the calculator. So this is log 2 divided by log 32. And that is, you get either 0.2 or you can make it 1/5, which makes more sense because it's 32 raised to the 1/5, which is the 5th root of 32, which equals 2. So it's also 0.2, so it wouldn't be wrong either way. Okay, same thing for this one. you know what I'm doing. So I got -4. This one I got 0. This one I got 6. Okay, now we're kind of graphing the log by graphing the exponential function. So I'm just going to pick a few points. So I'll just pick -1, 0, 1, and 2. And so we plug them in. So 10 to the -1, that is 1/10. 10 to the 0 is 1. 10 to the 1 is 10. And 10 to the second power is 100. So make sure you know what I'm doing. I'm just plugging it in for x right there. Then we're just going to swap the x and the y. So that means this will be 1/10, -1. See how they're switched? And then 0, 1 becomes 1, 0. 110 becomes 10, 1. 2, 100 is 102. And then it just says graph the logarithmic function. So we're going to graph that one. So 1/10, -1, it's like about right there. 1, 0 is about right there. 10, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10, 1, about right there. And then 102 is just way off, so I'm not going to be able to graph that. So the shape goes like this. Goes through, okay, basically like that. All right, so end behavior. So as x approaches infinity, you can see here, x is approaching infinity. The y value is getting bigger, so y is approaching infinity. As x approaches, and what happens here is that it's approaching the vertical asymptote, which is right at x equals 0, and it's approaching it from the right. So as x approaches 0 from the right, y approaches, and that's -infinity because it's going down forever. All right, so similarly here, we have a different function, different logarithmic function, but exact same process. So we're going to plot some points. Notice their bases are the same. So that's a base 4, that's a base 4. Okay, so -1, that's 1/4. And we got 0, that's 1. We got 1, should be 4. Plug in a 2, we get 16. And then we're going to just swap x's and y's to graph the logarithmic function. So 1/4, -1, 1, 0, 4, 1, 16, 2. Plot those points, so roughly, maybe about there. 1, 0, maybe about there. 1, 2, 3, 4, 1, there. 16, 2, it's off the graph. So I'll just get the shape here. It goes like that. The vertical asymptote is the same. It hasn't been shifted or anything, so it's still right at x equals 0. So now we can talk about the end behavior. So as x approaches infinity, y is also approaching infinity. So basically the same as the last one. So x approaches 0 from the right, and y approaches -infinity. Okay, so now little transformations and see how that affects the domain and the range and the vertical asymptotes. Okay, so this one is shifted to the right, 8, and it's also up 2. All right, so that affects the domain because remember the domain was going to be x is greater than 0 like the other two we just graphed, but now it's going to be x is greater than 8. The range is the one that always stays the same, so that's going to be y is greater than -infinity and less than +infinity. Remember the vertical asymptote is going to be tied with the domain on these, so it's going to be x equals 8. Okay, this other one, the transformation looks like it only has 1, so it's just down 3. The domain has not been changed from those other two that we just graphed, so it's still going to be x is greater than 0. The range stays the same for all these logarithmic functions, so y is greater than negative infinity and y is less than infinity. The vertical asymptote is tied to the domain. Remember, these are the two that go together. So x equals 0. All right, we're going to change them from exponential form. We're going to change it into logarithmic form. So it's pretty simple. It's just log and then whatever the base is. So log base 10 of, in this case, it's 10,000, and then equals, and then whatever the exponent is, so 4. Okay, next one, we got log, and then whatever the base is 1/2, of 2 is equal to whatever the exponent is, so -1. Okay, we're going to go the other direction. So this is logarithmic form, we're changing it into exponential form. So it's going to be 4 raised to the -2 is equal to 1/16. Then we have 1279, and we raise it to the 0, and that equals 1. And that's true, because we know even if it's a big number, raised to the 0 power equals 1. All right, so now the log properties. All right, so if we have a bunch of things, we know that we can write them as one single log. So I'll try to show all the work here. So first we have log base 2, 4 plus, and remember how the 3 can go as an exponent right there? So that's log base 2, and that's x cubed minus log base 2y. Now what you're going to want to do to make this as easy as possible is you're going to just write log base 2 and then make yourself a nice little fraction bar, and then anything that's a positive log is going to be on the top multiplied together with any other ones that have a positive log, and then anything that has a minus sign, you're just going to put that one on the bottom. So it'll be really simple. So you have 4 and x cubed, both have plus signs. Like this one doesn't have a sign in front of it, so it's positive. So that means it's going to be 4x, it's going to be 4x, it's not letting me write for a second, so hold on. Come on, you little booger. 4x, there we go. 4x cubed, and then the y there is on the bottom, so then it just, boom, that's it. So I'll kind of circle that one there. That's 4x cubed, if you can't read that. All right, so this one, we're going to do the same thing. I'm probably going to move this 8 up as an exponent first. So log 11, I'll just rewrite the rest of the stuff here. Well, it's starting to cause me trouble with this darn stylus. Okay, so log, and then y to the 8th. And then minus log z. Okay, so we're going to set up our little fraction. So it's log, little fraction, and then anything that's positive is going to end up, see this one's positive, this first one. So that means it's going to have an 11 there. And then what else is positive? Is there anything else? No, it looks like everything else has a minus sign in front of it. So it's going to be x. Oops, I have the eraser going. It's going to be x, got that x, we got this is y to the 8th, and then we got our z as well, so that would go on the bottom. So that's your best answer there. And then let's see if we have any to move. Okay, so we have this guy to move as an exponent, and you can do that all in one step if you want. I'm just showing the work. Maybe I should not show the work. I should just do it. Okay, so this is log base 7, this is x cubed, and then we got the plus log base 7y. Oops. Okay, so we're going to just do our log and then base 7, make a nice fraction. Anything that's on the positive is going to be on the top. So I got a 2, it's going to be on the top. I got a 5, oops, I should have multiplied those together. Oh well, so 2 times 5. And then I've got the y. So 2 times 5 times y. And then the only one that's negative is just this one here. So that means that x cubed is on the bottom. So I would just multiply them together. So I would make that 10y. Ha. Make it 10y. I wouldn't even put a times there, so I probably would just make this 10y. Okay, so 2 times 5 times y. And then this last one here, let's see. So I'm going to do this in one step. So that's going to be z to the 4th, right? So we're going to do log, and then whatever's positive is going to be on the top. But I don't see anything positive. So if there's nothing, then just put a 1 on the top. And then it's going to be, we got an x, we got a y, and then we have, this is going to end up being z to the 4th. Can you picture that? Because the 4 goes on the z. All right. Now we're going to split these guys up a little bit. So let's see. So we've got, looks like we have 1, 2, 4 different things multiplied together. So I'm going to go ahead and have 4 logs. So it'll be log base, let me write again. So log base, oh come on you little rascal. Log base 11 of 2 plus, and then what I'm going to do, I think I'm going to, I was going to move that 2 out in front at the same time. Maybe I'll wait on the first one. All right. So I got, next, we got, oh, come on, log, oh man, change stylist. Log, oh man, log 11, okay, x squared plus, and then log, technical difficulties, uh-oh. Okay, log 11 y plus log 11 z. Okay, so then the only other thing you could do is you could just throw the 2 out in front. So then it would be log base 11, 2, and then it would be plus 2 log base 11 x, and then log base 11 y, and then log base 11 z. All right, so this one, let's see, we're going to have anything that's on the bottom is going to be having a minus sign in front of it, and anything that's on the top is just going to have a plus sign. So it'll look like this. It'll be log, oh no, more troubles. Okay. Log base 3, 8, and then plus log base 3x. See how those 2 are on the top? They're separated with a plus sign. All these other ones on the bottom are going to have minus signs. So it would have minus, and then it would have log base 3, and it would have y to the 4th. So I think what I'm going to do is I'm going to take that 4 and I'm going to put it in front. So that's that third property. So this 4 is going to come in front right there. And then we're going to have another minus. So we're going to have a minus, and we'll have log base 3, and it'll be of z. Okay? All right, so now this one on the left, it's going to have, now we don't have anything really on the top. So let's see. Do we want to do a log 1? Let's do that. So let's do log 1. And then anything on the bottom would be minus. So it'd be minus log x, and then minus, and this would be log y squared. But what I think I'm going to do is I'm going to bring that 2 out in front right there. So it'll be log 1 minus log x, and then minus 2 log y. Okay, so this one we want to split up into 2. So we have x plus 8 quantity squared. So that's just x plus 8 times x plus 8. So probably just the easiest thing to do, if we had to make it more than one log, then we would do log x plus 8. And then I have to put my little base there. So that's a base 6. And then I have plus log base 6, and then I've got the x plus 8 again. So, right, if you combine those, they'd be multiplied together, so it'd be x plus 8 squared. Now, it is a true property to just take the 2 and put it in front. It's just that that doesn't turn it into more than one log. That just is still one log, okay? And I think that does it. Let's make sure. Yeah, I think I did number 26 a little differently before, but this is the correct way that I just now did it. All right, sounds good.